Hello everyone and welcome to today's webinar. My name is Janina Elliott and I'm the Central Technical Lead for Seequent, and it's my pleasure to present to you today the full mining solution. Now let's have a look at what we're going to cover today and how this webinar is organized. For today's webinar, I'm going to be using the new product versions for View, LeapfrogGeo 4.5 and Central 2.2, and overall this webinar is truly designed for a wide audience. So both if you are a completely new user of any of the Seequent products or an experienced one, if you come from a very technical space or even a more non-technical space, don't worry at all. This is really truly designed for everyone and is a broad overview to the entirety of the Seequent solution, specifically for the mining field. Our agenda for today, we are going to talk about the Seequent solution, as already mentioned, and we're going to discover where the value lies in employing the entirety of the Seequent product range in your organization. And then we're going to jump right into the active demonstration part, and we're going to start from the top down, speaking first about View, a communication and storytelling product, and then we can jump into Central and have a look on how we collaborate and data integrate through Central. And we're going to finish up by looking at LeapfrogGeo and, of course, Edge, and explore the idea of implicit modeling to everyone who's new to our modeling product ranges, and as well have a look at a number of workflow examples, how Geo, Edge, Central, and View all ultimately link with each other. Okay, so let's get going. Now, in this particular slide, what I'd like to point out here is our product range on the left side. So at the very top, we have View, followed by Central, and then our Leapfrog modeling suite. Now, when it comes to all of these products, you see here that they are placed in a particular order relative to an organization structure. This is a very common structure with the technical, strong technical base, and then the non-technical sort of C-level at the top, and even organizations that go beyond your organization, for example, which refer to public or public companies, for example, or government structures, etc., that influence your decision-making within your organization. Now, the principal idea is that all of our different products are really integrated with each other. So they really pursue the idea of data and information flow and transparency. And this is what they really want to establish for your organization too, so that you have the opportunity in the technical space to easily communicate with everyone in the organization, all the way up to the non-technical space. So the people basically with the purse strings attached. Now, what we're going to discover today is, as I mentioned, from the top down, each of these individual products and how they really can facilitate the flow of information in your organization, how they allow everyone involved to easily visualize data and actively collaborate with each other, ultimately allowing the entirety of the organization to make robust and quick decisions in real time in order to really keep that competitive edge for your company. So let's jump in, starting with View. Now, some of you might have already heard of View, others may not yet. View is a web-based storytelling tool that is available to everyone that has just one geo license, basically. It is completely free as a product itself, and it allows everyone in the company to exchange information, basically in form of a 3D PowerPoint presentation on the web. So it allows you to directly engage any stakeholder, particularly the non-technical field that is not quite as inclined probably when it comes to modeling, to engage with your information in 3D. This product also allows you to instantly provide feedback to your team and beyond, and really engage everyone in an unfolding conversation over time. It also allows you to take the story beyond your organization. You have the opportunity, for example, to send links to individuals outside of your organization to view 3D views, and to also publicly embed a view on your website, for example, to engage the public beyond that are influencing your daily decision-making process. So how does it actually work? I mentioned you basically just need a LeapfrogGeo or another Leapfrog modeling suite license in order to create a view. Within Geo then, for example, you can go ahead and create a link that you can email out to basically anyone at all. So for example, today we are going to email out a link to a C-level person that has basically 5 minutes to run around, you know, in their busy day with a tablet in their hand or their phone, for example, and just quickly click on that link and have a brief look at what I'd like to share. Now, what I have here today is, of course, a link. So I'm just going to follow this link. There we go. Click here, and we'll go from there. So let's have a look at view. There we go. Now imagine I followed this link and it places me right here into this particular view. And as I mentioned earlier, it is basically a 3D PowerPoint presentation, but it has so much more ability. So I've sent my C-level person this particular slideshow, and I'm trying to tell the story about my ore body. Basically, I'm trying to get a little bit more money out of that person in order to pursue more drilling. But how do I explain that to somebody that's not really in the technical field? How do I explain that to somebody that is an accountant, for example, or a lawyer, etc., but is heavily involved in that decision-making process? Well, the best way to do it is truly by providing a couple of images. And as the phrase goes, an image is worth, or picture is worth 1,000 words. And just take that idea, of course, to 3D level. It's worth even more than that. So in this particular image here, I'm showing where the ore body sits and the drilling around it. And then I'm heading to the next slide here that I can just click on, where it says the goal target. So my C-level person can quite easily click through these individual slides, read some of the different, the little stories that I'm telling around this particular slide. And what I've told my C-level person here is that we have a continuous trend in terms of our grade shell, and there is a potential target here. Now, in view, we have additional features that really allow us to tell the story by drawing, for example, onto that slide directly in 3D, by allowing to zooming in, by slicing through our individual pieces here, by allowing different elements to become opaque, or choosing different sizes, etc. So there's a lot of opportunity here to really visualize what you'd like to talk about, really tell the story that you need. In my case here, I had only had to draw one particular arrow that follows here the trend that we see in my gold mineralization, and I highlighted in a circle where I hit a potential target. So something that everyone can visually follow quite easily and basically ask more questions about or make decisions on. So my C-level person can see here, yes, there is potential, and there is a chance here if we put more drilling that we can actually expand our target. So that's wonderful. And now he or she can go ahead and provide feedback, and the conversation can unfold from here, which is really wonderful. So just as a summary, once more, view really fits into that non-technical space. It allows you to quickly and succinctly tell a story to anyone involved in the decision-making process by focusing on minimal data and allowing to actively create a feedback loop in your organization. So that's where view comes in. Okay. So let's have another quick little look at the PowerPoint presentation from earlier. So I'm just going to jump back here. Here we go. And now we're going to go ahead and jump into our next product, and that is specifically Central. Now, when it comes to Central, you may remember from the slide earlier that it sits really at the core in the center of the product range, but also when it comes to your organization. Now, Central is truly the place where we deal with geoscience data and where we really incorporate that information and allow flow through the organization. Now, for the people that haven't heard of Central before, what is it actually? What does that product represent? Well, Central is a data management system that can be rolled out on a server environment, for example, on-premise, or hosted in the cloud. And it helps you to visualize, track, and manage your geological data and models from a centralized and auditable environment. But what does that really mean? So Central allows you to basically version track all of your different models associated with one particular project. It allows you to build a consistent history over time, and with each individual model upload, you have the opportunity to actively annotate, comment, and collaborate, exchange information, not just in terms of intelligence, but also in terms of physical data. And because of that, you can truly manage all of your geological information, your geoscience data from a centralized environment and build a consistent audit trail throughout. So at any given time, you can come back to major decision-making points in your project development and actively show why those decisions were made and a certain path was taken, and then always making sure that everyone always works with the latest information, the latest version, and has everyone else's ideas and comments in mind. So it truly helps bring projects teams together and helps you stay connected and enables your team to make confident decisions when it matters the most. Now, as I mentioned, it is a server system, and our server system has 3 different gateways. Now, one of the gateways is, of course, your Leapfrog modeling suite. So let's say Geo, for example. This is a place where you can actively publish or upload different versions of your model into the central server, but where you can also download models of your colleagues and individual objects from your colleagues in order to inform your own modeling progress. The next gateway is the central browser. The Central browser is a desktop application that allows you not only to view the consistent history that you've built in your project environment so that you can see all of the different models that have been in place over time and actively compare it, but it is also an active collaboration platform. So this is where you can visualize, but also annotate, comment, and really encourage a conversation around individual models or even ideas of models that you've placed into the server environment. The third gateway is the Central Portal. The Central Portal is a web application that has the opportunity for an administrator to absolutely make sure that only the people that have permission to certain objects and ranges of data, to truly just have access to that particular information. So it is the place for the administrator, but it is also a place starting at the beginning of July for our new data room. So the data room is a place that we're going to explore in more detail later on. This is kind of new to a lot of people online, no doubt. And it is a data storage or management platform within the portal that allows you to integrate or to introduce basically any kind of file format, any kind of information that truly informs your specific project. So we're going to explore that space a little bit later on. In addition to that, the portal is also the place where we manage our partner integrations. And this takes us to a topic in Central that is quite interesting. We are starting to partner up with a whole number of different organizations at the moment, namely Index and others that are in the making, that allow us to retrieve information into the Central environment, truly use Central as a platform or a stage where you can truly integrate all of your geoscience data and not just the one that is created within the Leapfrog product environment. So we're really aiming, as usual, to interoperate with everything that's on the market so that you can make the best decisions based on all of the information that you create with all different products at your fingertips. Okay. Well, let's have an active look at all of the individual gateways of Central. And let's get started today with the Central browser. And here we go. Now, just to reiterate, the Central browser is a desktop application, and this is something that you can download quite easily from the My Leapfrog environment and then employ on your computer. Now, within here, you have the ability to connect to a server, and you see on the left side here, I have a whole number of different servers available to me. Now, I'm connected to my beta server at the moment because I always want to show you the latest and greatest that we're working with, of course. And then on the right side here, you see a whole number of different thumbnails. So if you're already used to working with the Leapfrog product modeling suite, you're quite familiar with the idea of thumbnails. Now, these thumbnails here are relating to Central projects, and Central projects are truly placeholders for your entire project history that we have evolved over time. So I'm just going to go here to one of my representative projects, and that's the Wolf Pass project, by clicking on this thumbnail. Now, as soon as I'm placed into this thumbnail, I am hopping here onto the History tab that presents to me just exactly how my project has evolved over time. So you can see on the left side here our project tree, which is truly a remarkable graphic that allows you to really follow the thought process over time, and in particular the temporal history of individual model uploads. You see that every single node here is structured along this tree is representative of a model upload. And each individual node here is actively associated with a bit of metadata that gives you an idea of why this particular model was uploaded, what the purpose was, and what the content of this particular upload is. In addition to that, you also see a number of different branches coming off from this structure here. Now you have the opportunity within Central to really, so to speak, divide and conquer. So you have an opportunity here to break up your projects into more consumable chunks that are easier to deal with, that are more effectively run, and that reduce the general background database so to run generally faster. So the idea is that you can separate out the individual models by, let's say, skill set, for example, creating a branch specifically for somebody that works in the resource environment or a structural model, etc., etc. You can also break out individual branches if you just want to pursue an idea, for example, you just want to test something. And the beautiful thing is at any given time, you can then stop this particular branch and say, okay, I'm happy with my idea. It's gone through a peer review process, and now I can go ahead and bring all of my information back into a master environment or a larger scale model that really needs that information. So there are lots of different ways on how you can structure your models using Central, and we're going to come back to that idea later on. But let's focus a little bit more on what we can physically see here and what the desktop browser presents to us. Now, representative on this particular upload, we see here that we've got a couple of stage labels available to us. And these labels here are completely customizable. So you can make sure that you always give the right label to the right model upload, informing your team just exactly by what it is that you've uploaded. You get a date, a name, and then a comment section that allows everyone to understand why this model has been placed here in the first place. On the right side here, you get to see a little bit of extra metadata. So whenever I click here, for example, on one of these objects, I get an information about just exactly how much, in this case, drilling has actually taken place, and also what are the individual intervals associated with this particular spreadsheet, for example, etc., etc. On the very right, we also get a summary of the comments and the conversation that has happened around this particular model upload, and that is truly important. So here we are building a consistent audit trail of the conversation that has taken place and all of the decision-making processes that might have taken place in this conversation. The beautiful thing about Central is that it records this information not just in form of text and dates, but also in regards to a physical 3D place in your model, which means that you can actively understand just exactly what this conversation is about by visualizing the 3D component in your model itself. So we can utilize this thumbnail here to navigate just exactly to the comment that Penny made in this particular conversation. So I'm just going to go here to Show Scene. And now what happens is that we're placed into the Scene View tab and have instant access to this particular model. And we're shown a geotag here that talks about exactly the 3D space that Penny wished to talk about. So that is quite powerful. Now that I understand just exactly what this conversation is all about, I have then an opportunity to instantly reply or place my own comments in here, which are then consistently preserved within the Central environment. Now, in addition to this particular view here, you'll see a couple of other panels. And on the bottom here, for example, you can see a number of different dates associated with this view. Now, these dates here are really representative of the different uploads that have happened over time on that branch that we looked at earlier on. So just imagine that tree that we observed sort of placed on its side, so to speak. The neat thing here is whenever I hop to another version, let's say the latest version here, for example, instantly the objects I previously observed are loaded just in exactly the new version environment. So I can see the updates and the progress that has occurred between my August 8th upload here and the latest here in May. Now, once this visual information has been loaded, it's been cached on your computer, so it's really just a small amount of data. And now you can really use this for instantly switching forth and back. There we go, and compare the information. So this doesn't only become a visual feature for you to observe the data, but it also becomes a presentation tool potentially. There are a couple of other features I'd like to briefly highlight. One of them is the compare button, which allows you to really track progress more easily even. So if I click here on compare, what happens is that I'm placed into this compare tab, and now I have the opportunity to juxtapose two different versions of the model within one view. And that's very powerful. So let's choose here once more the latest version of my model that also contains lithology and this day-side mesh. And you can already see here in the background how for each of these components, two different versions are loaded, the latest and the one from August 8th, 2014. Now I have in this panel different enhancement options or filter options that allow me to really see the differences between the two different versions. So for the drill holes, for example, I'm just going to click here onto this enhance difference button, and then on the bottom here I can choose to increase or decrease the radius of my drill traces here in the different versions. So I'm just going to increase the one for the later version, and I can see all the additional data that has been placed into my model since 2014. And then of course I can go ahead and visualize the differences here in the volumes as well, which are of course informed by the additional drilling that has occurred over time. And of course you can bring in as many objects as you like. The only thing you have to remember is that they need to stay consistent in terms of the naming convention, but other than that, you have lots of opportunity here to actively juxtapose information over time. And then of course, and this is the very important aspect, to actively talk about it. So you can provide annotations in 3D space on your juxtaposed views as well. Okay. So let's have another look here at the scene view, and let's talk a little bit about the panel on the left. Now on the left side here, we see that we have a whole number of different objects loaded, and this is very similar to what you're probably used to from the geo environment. Now the beautiful thing here is that some of these objects are actively exportable. So they're not just viewable through the different viewing options and buttons here, but also exportable. And this refers to, at the moment, to polylines, geotiffs, meshes, and block models. And that is quite powerful. So for example, if you work with somebody that is not a modeler in the Leapfrog suite and uses a different software program. So let's say, for example, you outsource your resource estimation to a third party, a consultant, for example, and you don't necessarily want to have to go through that process of zipping up your project every 5 minutes and then sending it over and then hoping that that person gets the link or has the capability of bringing it down onto their computer. They can utilize the browser environment. Within here, you can give somebody access from the outside, make them a viewer with exporting rights, and they have the opportunity here to go in and pick, let's say, a litho domain, for example, from the latest version of your geology model. So they can just go here, pick what they need, right-click, and choose export. And in the interest, of course, of interchange between different software products, that person can go ahead, pick any surface or volume that they like, and of course, export it into the file extension that they require in order to make it work for themselves. And the same thing occurs here with the block models, the polylines, and the geotiffs. So this is quite powerful and allows your team to access information through the browser environment that allows them not to have to go through this painstaking process of zipping up information, putting it somewhere on a server or even a memory stick and handing it over physically, or having to maybe wait until that person comes back from exchanging with their cross shift, etc. So I think you can already see the advantages that this can bear. And Central has many more advantages that allow for instant exchange of visual as well as physical data types. Okay. Another aspect I'd like to mention today that the Central browser can do for you is the integration with other partners. So for example, I can integrate my project with the Index Hub IQ, and I'm not going to go into as much detail today, but just to give you a brief idea what this is all about, by clicking this button here, I have the opportunity to directly link into the Index Hub IQ cloud, and I have an opportunity to retrieve almost near real-time drilling information, survey data, and structural information collected through the IQ logger into my central view. And the powerful aspect here is not only that I can observe drilling information as it comes in from the drill and make robust decisions right away there, I can actively compare that information with my ongoing 3D modeling progress, and of course any other information regarding drill planning, targeting, etc. So I can really say whether my targets hold true or whether my model holds true if new information need to be regarded, such as structural discrepancies, etc., targets either not being there or even more being there than I expected, etc., etc. So there are more and more partnerships similar to this being integrated into the Central environment, and it's really worthwhile keeping an eye on this particular space. Now, I mentioned earlier we've got 3 different gateways in order to connect to our server environment. And the next I'd like to show you today is the portal. So let's have a look here at my web browser. And now we're placed into the portal environment. Now, the central portal here is a place mostly for the administrator in order to create a permission structure around each project. And how's that done? It's quite easily accomplished. So I'm just going to go to one of my projects here that I opened earlier that we see. So that's the WolfPass project. And so once I do, I get a general overview here on the different activities that have happened in this particular project. And I get to see who is actively involved in this project and who gets to do what and gets to see just exactly what data. So for example, I can go ahead and I can make an individual a viewer of my files. So this is somebody who's not an active modeler, who's not actually potentially even using the LeapfrogGeo or Leapfrog modeling suites, and just wants to see the data and maybe even export maybe individual files directly from the browser in order to partake in the conversation around the modeling, but not actually actively model. So these are often high-level decision makers or third-party consultants, for example, or JV partners. Now, other levels of interaction can be set here. One of them is the editor. So this is where you become an active connector. And what that means is that you have the opportunity to link into the central environment through your Leapfrog modeling products, such as Geo, and actively publish information into the central server and also download from there. So that's what an editor can do. And then, of course, we've also got the owner level. The owner of a project has the ability to add individuals or remove them from the project and make sure everyone gets to see just exactly what they're supposed to see. And then overriding level beyond that is, of course, the administrator that has the ultimate power, so to speak, within the entire central server environment. So you've got different levels of permissions, different levels of MCs, basically, or masters of ceremony, that really keep track on exactly where the data goes, what is done with it, and keeps everything neat and tidy within here. Now, I mentioned earlier that within this version of Central 2.2, we actually have a new feature associated with it that not everyone has heard of yet, and that refers to the data room. So if I go here now to the Files tab, I open up the data room, and this is basically a folder structure environment where you can place any of your geoscience or project-related information. Within the data room, you can store absolutely any project file type. So let's say, for example, you want to retain information regarding PowerPoint presentation, reports, Word documents, or more importantly, even modeling information coming from other software products. For example, let's say wireframes and meshes created in Vulkan, Datamine, MineSight, whatever you have it, that you wish to record in your geoscience project space. That's what the data room is for. Now, you might ask yourself, okay, so this is neat, but why is this any different from SharePoint, let's say, for example, or Dropbox, etc.? Well, let me show you. So I'm going to go ahead and I'm going to follow here one of my folders, and I'm going to step here into what is more or less a substructure of my folder. So I'm going to observe here one of the files that I have introduced, my Northwest mesh as built. And now, and once I click on this mesh, you see here that a file history tab appears. Now, this particular file has been updated over time, and with each consistent update, a temporal history was built. So indeed, each individual file that you place into this environment can be version tracked over time. The neat thing here is also that each individual file doesn't actually need to be named exactly the same thing every time. The important thing is that this is a temporal history that is being built over time. And each individual file here is completely accessible. So it's not getting overwritten, it all gets stored just within a chronological order, so that everyone within your team has the opportunity to always navigate to the latest version of your particular file. And while I'm presenting meshes here, just to reiterate, this refers to basically any file type that you can imagine that you want to load and that you want to preserve for your project history. Now, in addition to this, there's one extra feature which really makes the data store stand beyond any other sort of file sharing product that you may employ at this point, and that is the opportunity to actively link this information directly to your modeling suite, such as Geo, for example. At this time, you have the opportunity through the data room to actively link to meshes or any kind of wireframe format, DXF, for example, or any extension relating to that. And you can actively bring this information into your LeapfrogGeo environment. And the nice thing is, as soon as a new version of this mesh is loaded into this file history, your LeapfrogGeo environment will be notified by this event, and you can instantly take advantage of this dynamic link and upgrade the file within your modeling effort. So I'll come back to this particular aspect later on, but this is truly what the data room is for, in order to facilitate not only the repository of your project-related information, but also the integration of geoscience-related files to your ongoing modeling effort. Okay. Now we're going to have a look at the last gateway to our central server environment, and that is leapfrogGeo. So in leapfrogGeo, we have the same connectivity opportunity as we've seen earlier, and we can connect directly here to the beta environment, and I'll present it with the same thumbnails or the projects that I've been personally given permission to through the portal environment. So now I'm going to navigate here to my WolfPass section, and you can see here that I get to see exactly the same sort of history that the browser has enabled me to see earlier on, including some of the commentary that is included in my history and has been created over time. But let's get into the scene view here, and let's have a closer look at leapfrogGeo. And just for the people that have never actually seen this modeling program, I'd just like to reiterate quickly what it is all about and why leapfrogGeo really stands out as a modeling product. Now, something that a lot of you will have heard of is the fact that leapfrogGeo is an implicit modeling program, while a lot of the other programs out there tend to be explicit. Now, what is the exact difference between the two? Well, let's talk about that in a bit more detail. And for this purpose, I've downloaded or already present here a couple of visual pieces of information that will allow you to talk or to understand the idea of implicit modeling. Now, let's just briefly review what explicit modeling really is. Now, explicit modeling, as done in many other programs, allows you to introduce information into your system in this fashion that you're used to via spreadsheets, Acquire, etc., etc. And but then you have to go ahead, and each individual point that you wish to model in a 3D space, you have to go ahead and digitize on your own. So each individual contact, for example, that you noted in your Joho environment, each interval, etc., will have to be digitized. And then you have to go ahead, introduce sections, for example, look at the interpretation of the sections in a sort of 2D plus space, and then go ahead and string them all together, all the individual contacts on a section, and then eventually extract that information into the 3D space and wireframe or volume. Now, once you've done that, you then have to go ahead to the next volume next door, and so on until you build up an entire geological model. That's basically the idea for explicit modeling. But now imagine you've come into the field and you've got brand new information that you've created and you want to introduce that back into your explicit model. Well, basically, you have to go through the same process again. So you have to introduce all of your new drilling information, all of the new data that you wish to digitize in 3D space, and then you have to make sure that it fits against everything that you've created previously. And that means you don't only have to go through each individual section, but you have to reinvestigate each individual wireframe and make sure that they actually fit against each other. So you don't open up any cavities, any open volumes and spaces that are not accounted for in your system. And that is not an easy thing to do. And I have a lot of respect for all of the modelers out there that are professionals in this space and do extremely well in the explicit world. It's not easy and it takes a lot of time to learn the skill well. Well, Leapfrog tackles this idea a little differently. And this is where implicit modeling comes in. Now, the principal idea is that Leapfrog has the opportunity to read CSV sheets or information coming from a database provider by an ODBC link, and it instantly digitizes the individual contacts and intervals that it reads in and registers is in a 3D space. So it instantly digitizes the points and knows where they sit relative to each other, and they are instantly available for use. Now, these points are the foundation for surface development or mesh development within the leapfrogGeo environment. So what exactly happens here? So let's have a look here on the left side. Let's say we've introduced a whole number of different raw data files into these folders here. So we've put in a topography, for example, which we can visualize here. We can put some beautiful GIS data that we can instantly drape onto this topography and other surfaces, of course. We can introduce here our drilling information via spreadsheets, ODBC links, etc. Bring in all of those points, and then we can bring in other information types such as points, polylines, structural data, other meshes, and so on. Once we've done all of that and we introduced our raw data in order to model, we can then go ahead and move to the geological models folder. And for today, I've already prepared a little model for us, so we don't have to go through the whole process. But the principal idea is that our lithological model here, what we do is to create an environment in which we want to model. And I'm just going to bring that in here, which we consider an output volume. So we start off with a volume that's already given that we need to fill in basically with lithological information. So instead of explicitly build one section or one area after the other and then eventually come up with this full volume, we already start with a full airtight volume that we then need to infill with lithological information. And how do we exactly do that? Now, I mentioned earlier that from the existing drilling, for example, or other information, we already digitize 3D points in space that then can be interconnected with each other. So Leapfrog runs on an algorithm which we call the fast radial basis function, or fast RBF. And this is akin to kriging, and basically is a statistical algorithm that allows us to look at all of these data points coming from the intervals and other file types and instantly run this algorithm in order to understand what the statistical possibility is for each of these points to be connected with each other. So a surface is being built on the probability of how the points fit with each other. So we can utilize the math in the background to inform our geological modeling. But this is just the first step. So we can use the math, and then the geologist comes into place and has all of the individual features built within the modeling product in order to then turn a mathematical surface into a true geological surface by applying his or her skill set. So how does it work? So here, for example, in my lithological model, I have the opportunity to build a whole number of different types of surfaces and volumes depending on what I wish to build. Now, I've already built a few of them, and one of them is my overburden unit. How did this work? So I'm just quickly going to show you how that's done by focusing in here just on the intervals in question, and those refer here to my recent. There we go. And what I'm going to do now is I'm going to pull out all of the points that relate to this particular interval and where it contacts everything else underneath. Okay, so I've already done this earlier, and I can show you here the file that it has created and automatically pulled out. So these are all of the points that sit underneath these little intercepts here that truly really have to be strung together in order to form that contact between the overburden and everything else that lies underneath. Now, I've employed the mathematical algorithm in the background to create just that surface, and here it is. Now, this surface here is a mesh that takes all of these points into account, and you see it actively snaps to these individual points and builds a 3D surface. And as you can see here, of course, it's expanded quite a fair bit and it has quite a bit of variability. And what has happened here is I told the surface, in addition to being snapped to these contacts, that it also needs to take the topography into account in order to build something that is reasonable and that sits underneath the topo. Okay. Now, once this beautiful surface is built, we can tell the surface to interact with that initial volume that we've created earlier. So this is our overall modeling box, so to speak. Can be any kind of shape that you like. And now we need to make sure that this top section here is basically cut off and turned into an overburden unit. And how do I do this? It's fairly straightforward. All I have to do is double click here on my lithology unit, interact here with my overburden, place this into a chronological order. So all of my different units have to be placed into a cutting relationship. So what comes first, what cuts what. Then I click OK. And then instantly my output volume here, you can see it's running right now, interacts with the information coming from above. In particular, my surface chronology. And as you can see here, now my surface has cut off the very top of my box and has created my first lithological unit that I can now emplace here. There we are. And this is how it works. It is very straightforward. So we keep on going, interacting with all of these different surfaces here. There we go. And now my output volume will be informed by all of the different lithological units that I've built from scratch based on the fast zero basis function. And then in addition to that, of course, my lithological knowledge and how these individual surfaces have to react with each other, how they have to look in reality. Because of course, the geologist is still the person that makes the big decisions. It's not necessarily a mathematical engine, i.e. everyone still keeps their jobs. So let's have a look at this. The final outputs here. Here we go. This is how it all interacts with each other. There we go. Okay. So another aspect that I'd like to briefly talk about is, of course, I could talk about geo. My goodness, for another 2 hours, the whole day. No problem at all. But let's have a closer look at the interactivity of the product itself with Central. And what I'd like to show you now is one more time here my lithological model. There we go. And the ability to link information that somebody else has created directly to my model through the Central environment. So for example here, in the meshes folder, I have the opportunity, I'm just going to open this up, to right click and to import a mesh from Central. Now, when importing a mesh from Central, what happens is that I can actively link here to basically any other Central project that I have been given permission to. So for example, I can navigate now down to my WolfPass project. And here I have now the opportunity to retrieve information from my colleagues or even models that I have emplaced over time and data that I have collected in the data room. So you've got the project history here. So all of the full models that have been uploaded over time and all of the different volumes and surfaces associated with it. And also the files tab here that allows me to actively access my data room environment. So for example, just to show you here, if I go to Pit Designs, which is the folder that we looked at earlier, what happens is that each of the files that have been in place are represented here in form of its latest version. So if you remember that history that has been built for each individual file type, the latest version is instantly accessible here and can be pulled into this environment. So for example, here I can go on any of these files, click import, and instantly this little blue mesh here will appear and will allow me to utilize this mesh now within my modeling effort. The nice thing is that it can also be instantly updated. in case a new version has been placed into the data room. And what would that will look like? Well, let me give you an example, but an example utilizing the other option that we have available here, and that is through the project history. So let's say, for example, I want to use a particular mesh here in my modeling effort. Imagine the following scenario. I am a resource estimator and I'm using Edge within the Leapfrog environment. Now, Edge is our latest resource estimation tool within the Leapfrog environment, and similarly to what I explained earlier, it follows the same principles as implicit modeling in the sense that it is directly linked to raw data within this particular file structure here, and can instantly take advantage of any changes that occur within here and actively model from here. So if I pull in, let's say, a lithological domain that my colleague has built in order to build an estimator and eventually a block model within my project, I can do that. So I'm just going to click here onto my lithological model, choose a particular volume of interest, let's say the early diorite, and click import. And here we go. So I can put that in here. Let's have a look at this particular mesh. And here we are. Now, the beautiful thing is this particular mesh now I can link directly to an estimator if I like. And I've done that earlier. I actually gone ahead and I built this estimator and I linked it. In this particular case, the day site, but it could be any domain that I like. Okay. And it can come from the meshes folder. Now, this estimator here is all the way linked to a block model environment through individual hyperlinks, as you can see here, that exist throughout this entire folder structure. Okay, there we go. Now, let's say that my colleague has now worked on this particular lithological domain and has created an update that he or she has placed into the central server environment. Once that's the case, my model gets informed by that fact by creating a little clock symbol here on that particular mesh. Now, if I wish to update this mesh, all I have to do is right-click and choose one of two options. So I can either reload latest on branch, or I can go ahead and reload from a project history. So I can go ahead, choose latest on branch, then Central will climb up the ladder basically, pick the latest version of this model and brings in just exactly that. Here we go. Now, I mentioned the interconnectivity, of course, of all of the different file types. Now, this particular mesh, or actually this one, sits at the foundation of my estimator. Now, if an update has occurred, then automatically here, this information will flow all the way through my geological model, through my estimation, informs my estimation of the new extents of my domain, and informs everything else all the way down to the block model environment. And that's absolutely fantastic. Now I just have to go in and make sure that all of my previous selections are still holding true, or whether I have to tweak my model a little bit. But this is an absolute game changer, because all of a sudden resource estimation is now a process that is fluid. And it doesn't have to happen just once or twice a year, where we all go through a mad scramble trying to get exactly the right version of each lithological domain and trying to understand the geology, even if we're not actually involved in the thought process around geology and are just trying to create the best estimation we can, just purely based on data, but not necessarily an interactive conversation with the geologists that are actively working on the deposit itself, for example. So all of a sudden, Central opens up the opportunity for this process to become fluid, to become dynamic, and to really partake in the conversation and the interpretation around geology. So it does make a huge difference. And this particular idea of interconnectivity applies not only to the entirety of the leapfrogGeo environment and other modeling products that we create, so the implicit linking of individual features, but it also applies to more and more workflows that have Central at its core. And now I'm just going to quickly go back to my presentation to talk about a couple of small workflow options that you have through the Central environment. So let's just have a quick look at that. So modeling workflows of interest through the environment of Central. Now, the principal idea is, and I mentioned this earlier in my presentation, that we can really improve our day-to-day modeling within Leapfrog when stripping down our projects to a size that really makes sense for our desktop environment. We all know that with the onslaught of data that we all have to deal with. By trying to build holistic models that really take into account absolutely everything else that has been created, we're really reaching what is possible in our desktops of environment. So we're reaching the margin, the borders of what's possible in that data space. And one of the ways that you can actively mitigate some of those impacts, i.e. reduce process or slow down processing time, etc., is by utilizing Central. So how do we do this? One of the ways to do it is by separating out your large projects into more specialized components, and that really increases your modeling efficiency. But how can that be done, and how can you still retain full data visibility? And that is really through Central. So how do we do this? One way of doing so is by organizing your different Leapfrog projects within Central by data type. So we see once more here our structure, our tree, and we have the opportunity to branch individual projects here and separate them out from each other, yet retain visibility within the team environment. And these individual branches can, for example, retain models that maybe only contain one particular data component. So one of them could be, for example, only containing GIS information. We all know that images and maps, for example, really vastly increase the backend database for geo, and that is truly something that slows us down. But we don't necessarily always need all of the individual images or level plans or sections, etc., that inform our project. Some of them might become redundant. And so one of the things you can do is just to place a project with all of the images into this environment, and within the desktop environment, within the browser, each individual modeler has the opportunity to visualize all of the different maps by just clicking onto one of these nodes here, going into the scene view, and then within the scene view, that person also has the opportunity then to actively download a GeoTIFF and then actively use just exactly the specific image that they need at the time and that they're interested in. So they can really reduce their own individual geo project to a size that is manageable for the desktop environment and don't have to contain all of the information at all given times. So Central really turns into your GMP and not your individual geo project. Now you can also organize by location. So of course, this is probably the most straightforward idea that most people would have already thought about. So you can separate out by different sites, satellite deposits, for example, different zones, etc., and create a separate central project for each of them. And in each central project, you have the opportunity through the object integration link, that mesh integration I just showed you earlier, to leverage of each other's work. So you could even entertain to create a large master model that takes all of these information into account by linking the final results of each of these into a master environment. That master then stays really light because it's not connected really to anything else, or there doesn't necessarily have to be a full active database involved for drilling, etc. What it does live off are the final output volumes from each individual zone that are then physically or visually represented within the Geo Master project. So that's one possibility of using Central as well. Another one is the one that I already showed you earlier, and that's by organizing your particular Leapfrog projects by skill set. So we have a whole number of very specialized people usually in our organization. The resource estimators are one of them, our statisticians. But others are, for example, our structural geologists, our engineers, or a geochemist or a geophysicist, etc. All of these highly skilled individuals can have their own workspace, basically, in which they can work, and where they can actively leverage information from their partners in the project, for example, by retrieving, let's say, geological domains, and by reintroducing their own work into somebody else's environment. So with the example of structure, for example, you can go ahead and have somebody work on, let's say, the structural model locally or regionally, and then be able to actively link the meshes of their, let's say, fault network instantly to the geo model that somebody else is creating in parallel. So the two particular partners here can actively work with each other's information and be consistently updated when the other person is creating a new piece of information in that environment. And this really wraps up my presentation of the full mining solution. And of course, there's so much more we could cover. It's basically endless. And if you know me, I can talk for 3 days straight. have no issue with that. And I'd love to talk to you more about this. So please don't hesitate to get in touch with us after this. If this is new to you, if you'd like to have a bit of a better introduction to Central, for example, to View, and how it all interconnects with leapfrogGeo and our other modeling products. If you're new to Geo, for example, please don't hesitate. We'd be more than happy to go into more and more detail and really allow you to understand how the different products and the entirety of the Seequent solution can really benefit the entirety of your organization throughout by helping improve the flow of information through the different components of your organization, by being able to visualize this data and thus making robust decisions when they matter the most.